my snippet surrounded the statement, and I can just set my condition here. So if flag equals to 1, I get this message printed on the output. Let's execute with F5. We can see that we get the output on the screen. Now, if I set my flag to 0, I expect not to have an output. And you see that with an easy way of by using the surround with snippets, I completed my code. Now, let's get into a more sophisticated example on snippets. Let's create our own snippet. So for doing that, we have to add our snippet via the code snippets manager. Now, the basic question here someone might have is that how do I create a user-defined snippet? There is an XML template describing how you can do that. So I prepared a custom snippet that creates another test table, and let's take a look at the XML code. So this is my XML editor, and as you can see, this is the template for the custom snippet for SQL Server Denali. So here in the header tag, I have the title for my snippet, shortcut if applicable, description, author information, the type of the snippet. Here I'm using expansion. And down below in the code, I have my T-SQL code that is included in the snippet. So I saved this XML as custom1.snippet in a specific directory, which I named it custom snippet. So we can see my snippet is here. Now I'm going to add this directory via the snippets manager, and eventually my snippet will be included in the set of snippets in SQL Server Denali. So Tools, Code Snippets Manager. I'm clicking on that, and you see I'm selecting this folder, which I earlier placed my snippet, and you can see that my snippet is now included in the Code Snippets Manager. Click on OK, and let's use the snippet. So for this example, I'm going to use the TestDB database, and let's say I want to create a sample table in this database with specific name as defined in my snippet. So insert snippet, custom snippets, and I select the create test table snippet. So this is my code included in my custom snippet. I run this, and you can see that the test table was created. Great. Let's continue with the rest of the presentation now. And let's talk about programmability features. Full text search was enhanced as well in this CTP of SQL Server Denali. And now indexes can support property scoped searching. There is the ability to customize a proximity search by using the new custom near option of the contains predicate or contains table function. We can now use metadata discovery for getting metadata by executing a specific store procedure instead of just executing the T-SQL statement. We have the execute statement enhanced, where we can specify the metadata returned by the statement. So let's say we have a store procedure and it returns some set of data. We can specify, let's say, new column names for the data set that is returned by the statement, by the store procedure. There is UTF-16 supplementary characters collation, so there are even more character collation support in this CTP of SQL Server. Ad-hoc query page implementation, where using specific clauses in the order by clause, you can skip records or just have a subset, get a subset of records within the dataset returned by the T-SQL statement. And sequence objects, where sequence objects define specific objects that return numbers based on an increment option. It is like the identity, an identity column, let's say, but the sequence object can be used within the scope of an entire database and not just within a specific table. Now, regarding spatial features, there are some new sub-data types like a circular string, compound curve, curve polygon, supporting the circular arc. There are new methods supporting circular arc segments, and some additional static aggregate methods for geometry and the geography data types. Now, in demo 2, we're going to see the programmability features shipped with this CTP. So I'm going to use some sample code modules created for this demo. So I'm going to use this T-SQL script for showing to you metadata discovery. I'm going to use one of the supplied store procedures for doing that. This is called SP describe first result set, and it returns the metadata for the first possible result set of the T-SQL batch. So my T-SQL statement is select object ID name and type description from sys indexes. So if I just execute this T-SQL code, I get metadata information for my result set. Now, if I run the actual query, of course, I get the actual data. Now, we're going to see in the next demo the enhancement in the execute statement. The execute statement can now specify the metadata returned from a statement by using a specific clause. This clause is the with result sets argument. So I'm going to use the AdventureWorks database for this. So the traditional store procedure execution would return the data as specified in the target of the database object. This is a user-defined store procedure I earlier created, and it returns the department ID and name from a human resources department table within the AdventureWorks sample database. But if I want to get the same results, but to specify new column names for my result set, I can use with the result sets argument, specify the name